Here's number 29, section 1.3. It says tripling your money depends on how much time is required for an investment to triple in value if interest is earned at the rate of 5.75% compounded daily. Now this is a little tricky. Okay. So the amount we have or the amount we're going to have, we're going to take that amount and we want that to be triple, so we're going to have another amount. We can call that the principal. And we're going to multiply that amount here by one. Now, since we're going to compound it, the interest rate, the 5.75, we're not going to multiply it by 1 plus that every day, because that's a yearly rate. So that's per year. How many days are there in a year? 365. So that's going to be divided by 365, because we're going to have 365 equal days that we are going to be multiplying that. So we're going to take our principal amount and we're going to multiply that by 1 plus this amount. So it's a lot smaller because it's that 5% or 5.75% for the whole year, and we have got 365 days and we're compounding it daily. Okay. Now, how many times are we going to do that? Well, one day we would do it once, 2 days, multiply it again, 3 days, again. So it's going to be per year, 365 days. And how many years? Well, we don't know. That's what we're looking for. Now, we want the ratio of the amount to the principal to be triple. We want to triple our money. And like I said, if you started with $100, how much would you want? You would want to end up with $300. You would want to triple that. Well, it doesn't matter to be the same if it was 3,000. You start with 1,000, you want 3,000. Well, if you take that ratio of A, divide both sides by P, you would get 300 over 100, or you just get 3. So we want 3 to equal this 1 plus, and this would be our daily. Okay, and then we're going to raise that to the per year. So this will give you the number of years it's going to take to do that. Because we will do 365 of these, but this is a smaller interest, but we're doing it more times. Okay, so we just have to graph both these. Now be careful when you graph these, because you have to be careful with the exponents. So we'll set these equal to each other. So I'm going to put this in the calculator. And I've got parentheses here, and I've got 1 plus, and then I've got a fraction here, so I'll put a little parentheses around that just to be safe, and I've got 0, or 0.0575. That's right. Okay. And that's going to be divided by 365, parentheses. And I'm going to raise that. And then I have to put a parenthesis around the 365t, because otherwise I would just raise it to 365 and multiply it by t. So I want to do both, so I better put a parenthesis about that, and it's going to be 365, and that's x, because we don't have a t. Now again, if you didn't put the parentheses here, what it would do, it would raise it to the 365 power, and then it would multiply the whole thing by x, so you would get the same answer, or the correct answer, I should say. Okay, and then we want that to equal 3. Okay, so I hope you see how we put that in, and be careful on these parentheses. You have to understand how the calculators work. And then just graph this, and we can use our same setup and see how that works. That doesn't look like that worked really well, did it? What happened? What did I do wrong? Let's go back here. Okay. Something looks a little odd. Oh, I missed a parentheses. That's what happened. So sometimes you got to check it. Because we need a parentheses around there and a parentheses there. So I'm going to put second insert and put a parentheses. So that saves me a little bit of work. Now let's try that. Yeah, that's more like it. So sometimes if you get crazy stuff, then you have to go back and check if you forgot a parentheses. So that's a good thing to know. And there we go. And let's go to intersect. So we go second calculate, intersect 5. That first curve, we'll get a little bit closer like that. Enter, enter, enter. And we get 19.01 and 8. We can round it off. 108. So T is approximately, I can write that over down here, I guess. I'll write it over here so I can write over here. So this will imply from our calculator that T is approximately 19.108 years. Okay? Oops. And that's right off my calculator. Okay? And then number 31, color of bacteria. And getting back to the last problem, that second insert is really nice, so you don't have to redo the whole thing. You can just use second, and then we'll be put over the delete problem that will insert it, like over here, like I said. You just press second, delete that inserted, then that allowed me to insert this parentheses over here, so I didn't have to write the whole thing out. Oops, excuse me. All right, so that allowed me, because I needed a parentheses here, because I had a parentheses here, a parentheses around my fraction, and then I needed another one, so I was missing a parentheses. Okay? Sometimes that happens with the best of us. Okay, so 31, back to cholera. Suppose that a colony of bacteria starts with one bacterium and doubles every half an hour. Okay, how many bacteria will the colony contain at the end of 24 hours? So we start with one, and we're going to double it. So every time, so we're going to multiply this one bacterium, okay, by 2. How many times? Well, every half hour, and there's 24 hours, so how many half hours are there in 24? 48. So 2 to the 48. So that just equals 2 to the 48th power. Okay? Now if you want to work that on your calculator and see what you've got. Yeah. Now we talked about this before. If we're going to do something like this, we might want to go to our home screen, so we'll hit second mode or second quit. And then we just say 2 caret 48, enter. And we get 2.815 e exponent 14. That really means 10 to the 14th power. So we would write that as, so take a look in the calculator. And we'll say that that's going to be equal to, we can round it off approximately, 2.18, and since this is bigger than 5, we'll add 1 to the 4. All right? So 2.815, gosh darn, excuse me. Yeah, I'll just scratch that out. 2.815 times 10, and that's going to be exponent 14. So that's how you would interpret that, those real big numbers, 2 to the 48. Okay? So if that makes sense.